Hi, and welcome to the University of Stavanger, and welcome to your new life as university student. It is great that you decided to study at the Faculty of Science and Technology, and I am delighted to have you on board for the Introductory Physics lecture FYS100, covering the basics of Newtonian mechanics. In this lecture, you will meet students from many different disciplines, engineering, science, and teacher education, together with our staff at the Institute for Mathematics and Physics and our student assistants. We are really looking forward to helping you master this fundamental subject so that you have a firm basis to excel in your studies as you go forward. Let me say a few words about the lectures. This course consists of 3 lectures per week, all of which take place in the EOJ building, and on the canvas you can find a link to the maze map where you can find all of the locations and the time slots on the Timeplan. We have 3 lectures, one on Mondays 12:15 to 2, Wednesdays 10:15 to 12, and Thursdays 12:15 to 2. In the pre-semester week, we have also 2 lectures, August 15th 10:15 to 12, and August 17th 8:15 to 10. Let me share some experience from the time when I was a student, from which I strongly recommend you to really attend the lectures in person and actually take handwritten notes. It has been shown in many scientific studies, and you can find links to 2 of them on the canvas, that handwriting really helps the brain memorize and recall information, and thus handwritten notes will help you to learn the subject matter we discuss in the lecture. If you cannot attend the lecture due to some other university-related appointments, you can find recordings on the Panopto page, and I will share the link to this page with you during the semester. On Canvas, you will find an outline of the course in the form of modules, which actually correspond to the different chapters of our textbook, the FYS100 Mechanics by Survey and Jewett, the second custom UIS edition. Please make sure that you have a copy of this book for this course. Since repetition is an important element of learning, I actually expect you to read each chapter in full before we start discussing it in the lecture. In each lecture, we will begin with the Kahoot quiz, and you can find on the canvas a link to a YouTube video where you can see how these quizzes work. And through these quizzes each morning, you can get a feedback on your reading progress and reading success. Let me also tell you that in science there is actually 2 levels of understanding. There's conceptual and practical understanding. By listening to the lecture, taking notes, reading the textbook, and discussing the subject with your fellow students, you are developing the conceptual side of understanding. At the same time, you'll also need to practice the practical side of science, which consists of solving hands-on computational problems and carrying out experiments. Just analyzing a football game in front of the TV is certainly not the same as being on the field and playing the match, and you will really have to acquire skills and practice to be on the field and win this game. And as any athlete will tell you, it takes hard work and some discipline to achieve good results, but when you succeed, it really feels amazing. Let me say a few words about the tutorial sessions, which are an integral part of our course. Together with the student assistants, we offer you the opportunity to practice problem-solving skills by working on the weekly homework exercise sheets in dedicated tutorial sessions. You'll find these sessions marked as Öving in the Timeplan, and there's a link to them also on the canvas. In each of these sessions, student assistants are present and will gladly support you if you have problems with solving the exercises. Those exercise sheets are part of your assessment, and so you will have to successfully complete 6 out of 9 of these exercise sheets marked by your assistants each week. This is part of the qualification to participate in the final exam. Let me also share some experience about learning success. In the past, I have seen students fail to achieve the learning success they expected because they did the following. They found a solution to the homework problems online and then worked through the exercises while having the solution lying there open in front of them and checking with the solution when it gets a bit tricky. And let me tell you, this will not allow you to train the relevant skills that you will need when solving genuinely new problems, which is what you as a researcher will be doing in your job later on, or what you need to do during an exam. Now that there's also many other ways to cheat yourself out of learning success, you may think about using artificial intelligence tool, ChatGPT, or dedicated paid services online to solve the exercises. I strongly recommend that you do not waste your money on them, since the final exam will be an in-person exam held on campus where you will not have access to any of these tools. Practicing the hands-on problem-solving skills in the tutorial session and of course at home, because you will need more time to solve these exercises than just what you have in the tutorial sessions, may feel bothersome to spend that much time. But as you make progress and acquire more and more skills, you will see that you benefit from each of the exercises that you have solved. Let me also say something about laboratory exercises, because besides computational skills, researchers need to train their ability to carry out experiments. And I therefore introduced this year 2 laboratory exercises as part of this course. They are held in the physics laboratory in the Schelf-Egelands building, and there's also a link on the canvas to the map. You will get hands-on experience in setting up, conducting, and evaluating the resulting data of such kind of an experiment related to mechanics. And the first of those exercises will be held at the end of September, the second at the end of October. And as real-life work happens in teams, you are invited to form groups of 3 students to work on those laboratory exercises. During the semester, you will then be able to sign up for a time slot over a period of 10 days at the end of September and another period of 10 days at the end of October to carry out that experimental work. After the work is done, you're expected to write a report on it. The laboratory exercises are also part of your assessment, and you need to successfully complete both of them to participate in the final exam. Our student assistants and our lab engineer will be present to help you and guide you through these laboratory exercises. And with that, I can only say that I'm very much looking forward to exploring an exciting chapter of physics with you over the coming months, and I wish you a lot of success with FYS100. See you soon.